Hello, in this video we're going to go through the whole semester 2 exam from last year. So it's going to be probably a long video. First of all, section A, technology free. So it's a shorter one, okay, so only 30 minutes writing time. In your 7 minutes reading time, make sure you're wise about which questions you're going to answer. Never really do things in chronological order. If you're just going from question 1 to 5 or whatever it is, you might be wasting time. Use this time to think about which questions you can do, okay, and then go back to the others. Now, in reading time, so VCE rules here, you are not allowed to fold paper and you're not allowed to mark paper, okay? So if someone said you can mark with your fingernail, you don't really want to be caught doing that. You are allowed to look in your bound reference though. Okay, so you can look in your bound reference, but you can't go on your calculator. So also use that time to go through your bound reference, and you can mark pages in your bound reference if you want to. Okay, let's move on. Okay, so this one here, no calculator, no notes. So yeah, so in this reading time, you can't go through your notes, obviously, but use it wisely. Think about, well, which ones can I do? All right, question 1, factorize the following. So your questions should start off easy and get harder. But that doesn't mean you have to do them in that order, but just so you know, usually they're written from easiest to hardest. This one here, straightforward factorizing question. Think of two numbers when multiplied give you -35 and when added give you 2. So you're thinking of factor pairs basically of -35. I think, well, let's just set up my factors here. So 7 and 5 I know add up to 35 and the difference between them is 2, but one of them has to be negative because this is a negative here. Because this is positive, obviously it's going to be +7 - 5. And that's what you need to do. Don't really need all that space. Okay, next question. X + 5 squared - 16. Whenever I see it in turning point form, I immediately got to think of difference of perfect squares. Okay, so if you have it in turning point form and this is a negative, then you can factorize it using the difference of perfect squares. If it is a positive parabola, so you have no negative sign in front of this bracket, and this is a negative, then you use difference of perfect squares. If this is a positive, you can't use the difference of perfect squares. But if it's in this form, you can use difference of perfect squares, because this one will be, if you think about your parabola, will look like that. Okay, so it's crossing twice. If this was a negative, your parabola is going down, you can't use the difference of perfect squares. So make sure you understand of all the different situations you can use difference of perfect squares. I know in the past I've explained that in detail. So even if you go back to a video on difference of perfect squares or something along those lines, I don't know whether I actually did it. Okay, difference of perfect squares. Let me just write the formula up here. So a squared plus b squared is equal to a plus b, a minus b. Now, straight away you might think, well, this isn't a squared b squared, but it is. You've got brackets here. Your a is x plus 5. So even if you wrote a is equal to x plus 5, let's put it in brackets just for the fun of it. And then b is 16, or not 16, square root of 16, which is 4. So when I write this, I'm going to have a, which is x plus 5, and you can put in brackets if you want, but you don't really need to. I'd only put it in brackets if you had a negative there. So all I've done is substituted into this difference of perfect squares formula. So the x plus 5 goes here, and the 4 here and here. Now let's just simplify. So x 5 plus 4 is 9. And then I have x plus 5 minus 4, which is 1. And if you need to check your answer, but you probably don't have time, you can always expand that, substitute in a number. whatever, if they're equal to each other, then you know you've done it correctly. But that's something you could probably do if you had a bit of time left at the end. Okay, this one here. If you see a coefficient of x squared, always think, can I take it out as a common factor? Yes, I can, because 3 goes into 9 and 30. So let's take 3 out as a common factor. So we're left with x squared minus 3x minus 10. And this time we're just factorising what we have inside the bracket. So the 3 stays there. And I say, well, what two numbers multiply to give negative 10 and add to give negative 3? So I'm thinking of factor pairs of negative 10. I know there's 10 and 1, not going to work. 2 and 5, yes, because the difference is 3. One of them has to be negative. So the bigger number has to be the negative to give us negative 3. You can expand that again to see whether you get this answer. If you do, you know you've done it correctly. Okay, let's move on to question 2. Okay, so here we're thrown in probability. Consider the following events: number that is a multiple of 3, an even number. Okay, so a random positive integer is drawn from the set of 1 to 20 inclusive. Find the probability of A and B. So you can, if you want to, do it as a Venn diagram. So you can think of all your numbers from 1 to 20 that have them in common, but I'm just going to look at multiples of 3 and which ones are even. Okay, so I don't really need to write them all down. So we have 6, 12, and 18. So if you think of your multiples of 3, 6, 9, 12, 15, 18, only 3 of them though are even. So the probability of A and B is 3 over 20. The probability of A or B, so in this one here, you could, I would use the addition rule. And I'm not going to write out the addition rule here, but the probability of A or B is the probability of A. So how many multiples of 3 do we have in 20? So basically you say 20 divided by 3 is 6, with 2 remaining, but we just got 6. So 6 out of 20 numbers is a multiple of 3. So when you think about it, 3, 6, 9, 12, 15, 18. Okay, even number, we have 10 of them. Keep your denominator as 20. Okay, so don't change it to a half or 3 over 10 because you're going to be having to add and subtract. And remember, this is a tech-free exam, so it's a lot easier to add and subtract fractions when you have the same denominator. Okay, now, and then we take away what they have in common, and we already did that before, so 3 over 20. So 6 and 10 is 16. Take away 3 gives you 13 over 20. And if you really were stuck, you could draw a Venn diagram. And when we did the multiple choice test, I saw quite a few students actually do the Venn diagram, which was pretty cool. Time consuming, but still good. My puppy's making a noise. Anyway, solve x squared plus 6x plus 1 equals 0 for x by using the quadratic formula. Give your answer in exact simplified form. So your quadratic formula, and I think I might have to stop soon to take my puppy outside. All right, I'm going to just stop there for a bit. All right, so she'll probably start barking in a sec, so we'll just keep going. All right, so here's our quadratic formula. Remember to identify A. So A is your coefficient of x squared, B is your coefficient of x, which is 6, and C is your constant. So in this one, it's 1. Okay, so just substituting them in. So we have negative B, so negative 6 plus or minus the square root of B squared, which is 36. 4 times A times C, so 4 times 1 is just 4. Over 2 times A, so that's just 2. So let's just tidy this up a little bit. 36 minus 4 is 32. And I'm going to simplify this third. So the square root of 32, basically you say what's the highest square number that goes, or perfect square that goes into 32, so it's 16. So we're going to have 4 root 2 over 2, and then I need to just divide both by 2. So we're going to have negative 3 plus or minus 2 root 2. And you could leave your answer like that. There's nothing wrong with leaving it as one solution. Well, it's not really one solution. You can leave it like that, or you can separate it. Okay. I was going to say, you could put your perfect squares or some surd stuff into your bound reference, but this is a tech-free exam, so wouldn't really help you there. All right, you can hear little Lucy at the back door. All right, moving on to question 4. So for the equation y equals negative x squared minus 6x minus 9, calculate the discriminant. So, and this was on your formula sheet as well, but it won't be for your exam in 2017. What am I doing? It's not that. B squared minus 4ac. So again, identifying A, B, and C. So A is negative 1, B is negative 6, and C equals negative 9. So B squared, see how I'm putting things in brackets? It's just because we've got so many negatives here. If we stuff up our negatives, we can make a huge error. Okay, so discriminant, negative 6 squared, when you square a negative number, you get a positive answer. Then 2 negatives here gives us a positive. So basically 4 times 9 is 36. Which is 0. State the number of solutions. So if your discriminant is equal to 0, we have one solution. And you could probably work that out by factorizing this. I think you'd take out 3, so it should be negative times x plus 3 squared, by the look of it. Okay, let's move on anyway. Don't want it to be a long video. For the equation y equals x squared plus 8x plus 1, write the equation in turning point form. So basically we have to complete the square. So x squared plus 8x. So we halve the 8 and then square it. Whoops. Don't have to do that though. And then because we added it, we have to subtract it, just because otherwise we're changing the equation. Okay, so whatever number is in here is what we're going to use. So 8 divided by 2 is 4. And then 8 divided by 2 is 4. 4 squared is 16. Plus 1 is 15. State the coordinates of the turning point. So remember, turning point form is y equals ax minus h squared plus k, and your turning point is hk. So a value of h here, because it's a positive, is negative 4, and k is negative 15. And again, if you want to check your turning point, you can use this formula, negative b over 2a, which would be 8 over 2, so negative 8 over 2, which is negative 4, and then you could substitute negative 4 into here and you should get negative 15. Okay, so just another way of doing it if you couldn't complete the square. Okay, let's move on. Question 6. Suppose that in a certain school of 100 students, 30 students play basketball, 40 play hockey, and 10 play both basketball and hockey. Draw this information on a Venn diagram. Remember, I like two-way tables, but let's do a Venn diagram. Let's challenge myself to actually do a Venn diagram. Okay, so we have 100 students. What do we got? Basketball and hockey. 30 play basketball, 40 play hockey, and 10 play both. So the 10 goes in there. Basketball, if 30 play basketball, 10 play both. So that means 20 are here, and 40 makes that 30. And then we have 100 students. So what have we got left over? 40. So just make sure that that all adds up to 100. Find the probability that a student plays neither basketball nor hockey. So we have 40 over 100. And that simplified is 2 over 5. And I'm guessing we have to go down here. Is that it for that question? Okay. I'm just going to keep that Venn diagram there and just rub this out a bit. Okay, find the probability that a student plays hockey given that they play basketball. Okay, so we're using conditional probability here. You can read it straight from your Venn diagram, or you could do the conditional probability formula. By now, hopefully you can read it from your conditional probability. Let's have a look at if we use colour. So this one is find the probability that a student plays hockey given that they play basketball. So we're looking at all the people who play basketball, of which there are 20. And how many of these play hockey? 10 of them. So a half. So kind of imagine if we had all 100 students in Kennedy Hall. So in Kennedy Hall, we have students who play hockey, students who play basketball, and some who play none. So we're only looking at the students who play basketball. Actually, I did that wrong, didn't I? It should be 30. Sorry, I didn't include this 10 here. So there's 30 students who play basketball. Then how many of those 30 play hockey? There are 10 of them. Okay, so try to imagine what that would look like. All right, let's move on to question 7. A bag contains 7 green balls and 3 black balls. 2 balls are selected without replacement. Draw this tree diagram. So we can have green or black, and then green or black, green or black. Okay, what do we got? 7 green, 3 black, so altogether we've got 10 balls. So 7 out of 10, 3 out of 10. And it's without replacement. So in this next one, we only have 9 balls left in our bag. So you can go ahead and do them all 9. Because I've already taken 1 green, that leaves that as 6. So let's just draw it because some students have trouble actually understanding this. So let's just draw our 3 black first because I already had the colour black. And then what do we got? 7. So in my first one, if I was to choose a green or a black, the probability of a green is 1, 2, 3, 4, 5, 6, 7 out of 10. Then I've taken one of those green out. Now I only have 9 balls left, and 1, 2, 3, 4, 5, 6 of them are green, and 3 of them are still black. Now, if you think about the other way around, if we've taken 1 black out, that leaves us with 2, but the 7 are still in. And you can just look at your branches because you still should add up to 1. Okay, and I'm going to have to scroll up here. Let's just move this. Okay. Oh, not good that should have done it to the side. Anyway, it's Find the probability of selecting 2 green balls. So we got green, green. Remember, we multiply along our branches and we add our possibilities. So we're just going to do 7 over 10 times 6 over 9. Now remember, this is a tech-free test, so you need to be able to multiply fractions. So 7 times 6, well, actually I'm going to simplify this 6 over 9 to be 2/3, because it might be easier to simplify here than what it will be at the end. So 7 times 2 is 14, 10 over times 3 is 30, which is 7 over 15. Then the next one, exactly 1 green ball. So you can have the probability of a green, black, and you can have black then green. So basically we add, there's 2 possibilities, so we have to add them. So green then black is 7 over 10 times 3 over 9. So that's the probability of green then black, and then we add the other possibility, which is black then green. So 3 over 10 plus 2 over 9. Okay, again, you can simplify this if you want to. So 7 over 10, and I'm going to run out of room. 3 is 1/3. And this one here, oh, right, plus, it should be a multiply. You can simplify it if you switch your denominators, your numerators. So I'm going to put that at 2 there and a 3 there. If I've lost you by what I'm doing, then just go ahead and do a normal multiply. So 2 over 10 is 1/5, and 3 over 9 is 1/3. And I'm going to have to do it over here. So 7 over 30 plus 1 over 15. So that's going to become 2 over 30, so 9 over 30, which is 3 over 10. I think it's really hard to remember. How many 3's in 9? 3. Okay. It's late at night. Hopefully I got that one right. Okay, so that was it. I did that in 22 minutes with a lot of waffling, so hopefully you would get that done in 30 minutes. Okay, so second one, a little bit longer. You are allowed your calculator this time and your bound reference. A good student wouldn't really rely on the bound reference, so make sure that you go in confident that your bound reference is there, but you shouldn't be flicking through it all the time. Okay, and I'll never forget, a few years ago I had in my further maths class, the very first question required Pythagoras' theorem, and the majority of the class were flicking through their bound reference trying to find Pythagoras' theorem, and I was just shocked, thinking, well, you should know what that is. You shouldn't have to look in your bound reference for it. So go in confident. You shouldn't rely on your bound reference. All right, let's quickly get through these 8 questions. Which one of the following parabolas has one x-intercept? Okay, so you need to know what the parabolas look like, okay, just by looking at your equation. This one here, I know we've got 2 x-intercepts, so one goes through 2 and one goes through -2. This one here has 1 x-intercept, and that is at 3. This one here has none. Okay, so this is a positive parabola that, oh no, sorry, this has 2. So it's a positive parabola that's been shifted down 1, so it has 2 possibilities. This one here, if I factorize that, it would have 2 factors. And this one here is a positive parabola shifted up 2, so it's got no x-intercept. So your answer is B. Okay, question 2. Y equals x squared plus 4x minus 12 in factorized form is, you can do this on your calculator. Actually, I should get my calculator up. Sometimes it comes up with an error message. Oh, beautiful. No error message. Okay, let's just make it smaller. Okay, so on your calculator, even though this one's easy, but I'll just quickly show you. If we go to algebra, factor, and you can just type it in, so x squared plus 4x minus 12, and we're factorising for x, and there it is. So x minus 2, x plus 6. Some of you, though, will be able to do it quicker than what you can type it into your calculator. All right, actually, I'm going to try to do as much as I can using the calculator. Let's go back to question 1, though, if we're looking at the calculator. You should know what they look like. If not, put them on your calculator. So you can either graph them, which is probably more time consuming than doing solve. I would actually just go through and do solve for each one. So obviously I can type a lot quicker than on my keyboard than what you can on the calculator. So you would just have your equation equal 0, x and see how many solutions you have. So even if you had, like, maybe you thought it was B, but you weren't too sure, you can just type it in. Okay, so you only need to type in the 1 and see what your answer is. 1 solution, awesome, let's move on. Okay, but hopefully going into the exam, you would be able to look at a quadratic and think about what its parabola looks like. Okay, question 3, the turning point of the parabola with the equation. Okay, so this one here, again, can do on your calculator. So I'll do by hand first because you should be doing a question like this without the calculator. It's a positive parabola. It looks like this. I know that because the coefficient or the number, sorry, there is no negative basically in front of my bracket here. If there was a negative, it would be a negative parabola. So here I have a minimum. So I can go through and cross out all my maximums. So now I've got a 50-50 chance of getting it right. But you should also know that your turning point, when it is in turning point form, is hk. Your value of h here is 2 and k is -8. Oh, sorry, that was just Siri. Okay, now if you couldn't do that, get your calculator and can't see. Just move that over a bit. Okay. Sorry, I'm trying to fit everything into the screen. It's not working too well. Okay. Can't move you over. Okay, so with that one there, you can graph it, or you can also use this calculus, which is, you know, going into methods, you'll learn more about calculus, but you can actually find your function minimum if you just type in your function, and I can't remember what it was, x minus 2 squared minus 8. Whoops. But that doesn't open, I pressed on the wrong thing. X minus 2 squared minus 8. Okay, so it's given you the x coordinate. That's all I really need. It hasn't given me 2 possible answers, so you can see there it's 2, -8. But again, you should know by now the turning point form and how to get your turning point from that. All right, question 4. Which one of these expressions is an example of a perfect square? So don't get perfect square mixed up with the difference of perfect square. Perfect square is in the form x plus a squared. So this one here is an example of the difference of perfect squares. This one here is just nothing. Okay, so this one here is also an example of the factorized form of difference of perfect squares. So basically we're just looking at C and D. So which one of these simplifies to give us a perfect square? So we can say, well, obviously they're the same. The only difference here is the negative. So we've got 6 times 6 is 36. 6 times -6 is 36. So it's not going to be a perfect square. So C, so this one here is x plus 6 squared, and this one here is x plus 6, oh no, that's neither. Sorry. That's something else. Okay, So let's just say, again, you thought, well, I think C is the answer. I think the problem with this question, though, from memory, is students were thinking of the difference of perfect squares. So you can also just go to factor, like we did before, type in your equation. So you think it might be C. And there's our perfect square, so x plus 6 squared. Okay, moving along, question 5. In the equation y equals a times x minus h squared plus k, changing the value of a will. Okay, so before I get to a, let's talk about h. H moves it left or right, k up or down. A is your dilation factor. It makes it either wider or narrower. It also reflects it if it's negative along the x-axis. But basically A stretches the parabola, makes it wider or narrower. Okay, moving along, question 6. The solution to a quadratic equation, blah, blah, blah. The equation that gives this solution is, so you basically have got to identify A, B, and C from your quadratic. So remember your quadratic is negative B, so in this case B is 3. B squared minus 4AC, so A is 2, C is 5. So this is your coefficient of x squared, this is your coefficient of x, and this is your constant. So coefficient, constant. So let's see. Question 7. Which one of these equations is symmetrical about the line x minus 5? So remember, if you have a quadratic, symmetrical just means if you had a line going through it and any vertical line is x equals, hopefully you remember that by now, and that line just splits it in two, so it makes it symmetrical. Think about the line going through the middle of your body. Okay, so basically the left side of your body is the same as your right side of the body. So which of these has basically a turning point at x minus 5, sorry. Okay, so this one here, now I can look at quadratic equations and know what the graph looks like. I know this one here, it's x squared and it's been shifted up 5. So basically this graph, an x squared graph, and it's just been shifted up 5. Okay, so its axis of symmetry is at x equals 0. So it's not A. The next one is the same, but it's just been shifted down 5. So something like that. Okay, still has the same axis of symmetry, x equals 0. This one here has a turning point at 5, 2. So if you think about 5 being down here and 2, oops, positive 2. Okay, so it's going to be something like that. So nope. The next one has a turning point at negative 5 and 2 up here. And that's your answer. So there's your axis of symmetry there. Now, again, if you can't think about these equations of what your parabola would look like, you can graph them on your CAS, although it's very time consuming to do it. So I would pick the one that you think it might be before you start graphing it. So you would actually need to graph this. Actually, you could do the turning point. I'll just quickly show you. So you can graph them, or like we did before, the minimum. So let's just quickly clear all that. So your axis of symmetry is the same as your turning point, the x-coordinate of your turning point. So if we're going to find the turning point, and these are all positive parabolas, so I can just go to, not that menu, calculus, function minimum, and then type it in. So if I thought it might have been, let's say C, x minus 5, and I've got to put brackets there, sorry. squared plus 2. And there it's got my axis of symmetry at 5. I want it at -5. So I can just obviously scroll up and press enter. The only thing that had changed is this positive, and then I've got -5. So use your calculator effectively. Graphing each one is not the most efficient way of doing it. So think about what it could be and then go from there. All right, question 8. Can't actually see the question, so let's make it a bit smaller. Whoops, not that small. Okay, so we've got a turning point at 1,8. Which of the following equations is not the equation of the parabola above? Okay, so this is a bit annoying. If I was doing this one, I would figure out one of the equations. Okay, so I am looking at this and I can see that it has factors x plus 3 and x minus 5. Just here, it's a negative parabola. So the only one that's a positive parabola is E, so I'd cancel out E straight away. And then what else can I see? It has a y-intercept at 7.5. So this one has a y-intercept at 7.5, but this one doesn't. Okay, so there's D. So I'd look at features of the graph first before I actually think about the equations. So just recapping this question, I can see it has x-intercepts at -3 and 5, which makes your factors x plus 3, x minus 5. So I can see B has that, and so is C. So if there was an x minus 3, x plus 5, I would clearly see that as wrong. Another thing I would look at, as I did before, is the y-intercept. So your y-intercept I can see is going through 7.5, okay, so along the axis, and D has it going through -15. So it has to be D, is not the correct one. I would not spend time checking all of them. I would maybe just put a little asterisk in case I had time to go back to it, just to see, well, okay, I've got time, I can check them all. You can obviously graph every single one of them. Do I graph here? Okay, so you can graph every single one of them, and obviously the one that doesn't match the other. So I would graph this one, maybe with 2 others, and obviously if it's the odd one out, it's the odd one out for all 5 of them. Okay, let's move on. Okay, probability. Which one of the following is an example of mutually exclusive events? So remember, mutually exclusive events have nothing in common. Okay, so numbers divisible by 5 and odd numbers. So when you think about divisible by 5, just think of your multiples, 5, 10, 15, 20, 25. Obviously there are odd numbers, so they're not mutually exclusive. Numbers divisible by 2 and odd numbers, so 2, 4, 6, 8, they're all even, so it can't be B. Sorry, it has to be B because they're mutually exclusive. Let's just check the others just for the fun of it. Prime numbers, okay, so you can have odd prime numbers like 7, so they're not mutually exclusive. Prime numbers and even numbers. Oh, no, sorry. 2 is a prime number, so we can't have that. And numbers divisible by 5 and numbers divisible by 2. So obviously 10 is both divisible by 5 and 2. So B is the only possible answer. Okay, question 2. 2 fair 6-sided dice are rolled. The probability that a double is rolled is equal to, well, this one's a bit of a tricky question, isn't it? You can, and this would be good actually to have in your bound reference if you don't already have it, a table actually outlining the possibilities. Okay, so this might take me a while if I was to do them all. The probability that a double is rolled, so the probability of a double, if you think about it, we can have 1, 1, 2, 2, 3, 3, and so on. So there's 6 possibilities out of 36, which is equal to 1 over 6. So the probability of rolling a sum greater than 10, is there any that we could eliminate? Greater than 10. So what do we got? 12, 11, 11. So it's good that they're symmetrical. 10. We want to be greater than 10, so there's only 3 possibilities there. So it's not A. The probability of rolling a sum of 7. So I'm going to start here. No, here, 7. Then we go with 7 and a 7 and a 7 and a 7 and a 7. Okay, so that looks like our answer. The probability of rolling a number that's an even number, so half of them are going to be even. The probability of rolling a sum less than or equal to 6. So let's just quickly do it. 2, 3, 4, 5, 6. And you can already see that I'm going to have more than 6 options here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 possible ones there. The probability of rolling a sum of 6, so sum of 6, 1, 2, 3, 4, 5. Okay, so it has to be B, sum of 7. All right, A and B are independent events where the probability of A is 0.3 and the probability of B is 0.8. The probability of A and B is equal to, all right, first of all, I know it's not going to be A or D. Why do I know that? Because your probabilities have to be between 0 and 1. Okay, so you need to remember that. Now, the probability of A and B, now they're independent, and I just did a video on independent. So this is, you have this formula here, which we didn't cover when we did independent events, but the probability of A and B is equal to the probability of A times the probability of B. So let's go back to our question. Okay, so probability of A and B is equal to the probability of A times the probability of B. So just substitute in what you know. So probability of A is 0.3, B is 0.8. 3 times 8 is 24, so it's 0.24. B. Okay, moving along. Question 4. The following incomplete two-way table represents the number of people who own a cat or a dog. The probability of randomly selecting a person who owns a cat but not a dog is 10 over 27. The probability of randomly selecting a person who owns a dog is, okay, so let's just, what's this? Probability of owns a cat but not a dog. Cat, no dog is 10. So I'm just going to fill this in. So 10 over a total of 27. It's 19. So I'm going to make that 8, make that 3, 12, 15. The probability of randomly selecting a person who owns a dog is 12 over 27. Wasn't even simplified. Okay, question 5. 23 students were asked whether they could ride a bike or swim. What is the probability of selecting a student who can ride a bike given that they cannot swim? Okay, so this one here, we're looking at those who cannot swim. So we've got 9 and 4 cannot swim. What's that, 13? And the probability of those who can ride a bike is 9. So 9 over 13. You can use the conditional probability formula there if you like. All right, for events A and B equals 0.7, A or B is 0.75 and A and B is 0.3. Which of the following could be the correct probabilities for A and B? Okay, so here you would use the addition rule. So probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. I know that A or B is 0.75. I don't know what they are, but I need to take away 0.3. When I add these together, so let's just call it X. So X has to equal, so if I add 0.3, 1.15, no, 0.5. So basically, I just got to see which one of these add up to 1.05. So 0.35 and 0.8 is 1.15, 0.2 and 0.2 is 0.4. This C is 1.05, let's just check, and that's 1.1. So C is the only possibility. Usually if you see there is not enough information to calculate these probabilities, that's usually the teacher couldn't think of another possible answer. So, all right. Question 7. A bag contains 4 blue counters, 1 yellow, 1 red. A counter is drawn from the bag and then a coin is tossed twice. The following tree diagram illustrates the possibilities. So we want to know the probability of selecting a blue counter and tossing 2 heads. So we want blue, head, head. So the probability of getting a blue is 4/6. And then a head, then a head. And there's no other way of doing that, so we can't add them. And just by looking before, it was, I didn't have to actually calculate what that would be. So your answer is A. Okay, moving on to the extended response. Just so you know, also this year there are 20 multiple choice questions. Last year there were only 15, so a few more multiple choice questions there. A parabola has the following equation. I'm just going to move this up a bit. State the transformations from the basic parabola to get this parabola, or y equals x squared to get this parabola. Okay, so also, just so you know, the extended response questions in 2017 are more application style. So you've got the context, not just a kind of like a skills-based question. Okay, so this one here, we have, so 5 means we move to the right, 5 units, or along the x-axis 5 units, and then down 1 unit. Determine the coordinates of the turning point, so that's 5, -1. Determine the coordinates of any x-intercepts for this parabola. Okay, so let's just scroll down. Now, that's worth 2 marks. You can do that on your calculator. You should really, to get 2 marks, though, do it without your calculator. You can use your calculator to check it. So to work out what this would be, you can just use difference of perfect squares. So remember, difference of perfect squares is a squared plus b squared equals a plus b, a minus b. So a is x minus 5 and b is 1. So I'm going to have x minus 4, sorry, and then x minus 6. So to find the x-intercepts, we'll let that equal 0. So we have x equals 4 or x equals 6. And you can solve on your calculator. So let's just solve now on the calculator to make sure I've got the right answer. I'm so tired. Okay, let's just move that so we can see the equation. Okay, x minus 5 minus 1. Oh, it's a bit wrong. Oh, sorry, I didn't let it equal 0. Good thing the calculator tells you that you've made a mistake. So 4 or 6, good, got the right answer. So what the problem there is, because it's an equation, you have to let it equal something. So you have to let it equal 0. Sketch the parabola. I always get frustrated when I've been marking your work and I get a sketch and students aren't sketching them. You just do it straight on your calculator. So let's go back to the calculator. Let's do a new page because it's easier than deleting stuff off another one. Okay, so let's delete this. So we had x minus 5 squared minus 1. Okay, so there's our parabola. The problem is we can't really see what the y-intercept is. So if you wanted to, we can just go window settings and just increase our y maximum. Let's see if 20 helps. No. What am I doing? Go away. Oh, don't even know what I'm doing. Sorry. Changing the window. Okay, so we can see that that's there. Let's move you out of the way. Okay, so I've got all the features now of my graph. I know already from doing the previous question that my x-intercepts were 4 and 6. I know that my turning point was at, I can't remember, 5, -1. So you just need your y-intercept. So if we go analyze graph, no, we go to trace, graph trace. Remember your y-intercept is when x equals 0. So we've got 0 here, or you can just type it in, see x. I'm pointing at my screen, you can't see me pointing. Here, x equals 0, 24. So on my graph, it's a bit of a pain that it's drawn this way, but anyway, just need to put the key features. So 24, 4, 6, and we want to be halfway for our turning point. And we shouldn't really go too far down because if this is 24, then 1 is definitely not there, but it's just, oh gosh, that should be going through 24. You will hopefully have a better hand when you do it. Okay, so drawing it like that is fine. I've shown all the features. It's only worth 1 mark. So obviously I wouldn't be too pedantic about it. All right, a parabola has the following equation. Determine the y-intercept. Oh, y-intercept, if it's in expanded form, is always the constant 8. And I like to write things as coordinates. So it should be 0, 8 or y equals 8. Calculate the determinant to show that the parabola has 2 x-intercepts. So I should get rid of all that red stuff, blue stuff. Determinant is equal to b squared minus 4ac. So your value of b is -4, so -4 squared is 16. 4 times -2 is -8. 8 times 8 is 64, but we've got 2 negatives, so that makes that a positive. And that gives us 670, 80. So therefore, 2 x-intercepts. So we probably should say discriminant is greater than 0, therefore 2 x-intercepts. Determine the coordinates of the turning point. So you can do this on your calculator. It's worth 2 marks though, so you should do it without your calculator. I've shown you how to do it on your calculator. I'm not going to do it again here because we're over an hour. So take -b over 2a. So it's going to be 4 over -2 times 2, so -4, which is -1. And then when we put -1 into here, we get y equals 2 times 1 squared minus, so it's +4 plus 8, it's 14. Oh. So the turning point is -1, 14. Again, you can do that on your calculator. Determine the coordinates of any x-intercepts correct to 2 decimal places. So because it's worth 2 marks, you shouldn't really be using your calculator. You should be doing it by hand. So this one here, I would use the quadratic formula. I'm not going to use the quadratic formula here because you should know how to use the quadratic formula. I'm going to just skip to the sketching, but I've forgotten the quadratic. 2, 4, 8. Okay, let's just do another page. What was it? -2, -4, +8. Okay, so we still can't see it. So let's just change the window. So it's the Y that I need to change, just make it a little bit higher. Make it 15. Move that out of the way. So if I couldn't do any of those things before by hand, then I can easily do it on my calculator. So your x-intercepts, you can go to analyze graph, then 0. So we go to the left, then to the right, and it's -3.24. And then we do the same for the other side. 1.24. And then your maximum, your turning point, is that -110. Oh, I got that one wrong. Okay. I don't know what I did wrong. I'm really tired. So I obviously made a mistake for this one here. So you might want to go back and check it. Maybe see where I went wrong. Okay. Probability. Nearly done. A card is selected from a standard deck of 52 playing cards. Let A be the event, the card is a diamond. B is the card is an ace. Find A. Okay, so card is a diamond. Hopefully you know your deck of cards. There are 13 diamonds, and that simplifies to a quarter. The probability of B, so there's 4 aces, and that simplifies to 1/3. The probability of A given B, so you can use the conditional probability formula. I always write the probability, but it's the same as saying the number. So how many cards are both diamond and ace? So there's 1. And how many are aces? So 4. So it's 1/4. Is there anything else there? Nope. Question 2. The probability of rain on any particular day is 0.3. However, the probability of rain after a day that it has rained is 0.75. The probability of rain after a day that it hasn't rained. Oh my gosh. I wrote this exam probably same time last year, being extremely tired. The probability of rain after a day that it hasn't rained is 0.1. Complete the tree diagram. I can do that. Okay. So the probability of rain on any particular day is 0.3. The probability of rain after a day that it has rained is 0.75. So we're going to have 0.75 here. And also 0.75 here, because it kept raining. The probability of rain after a day that it hasn't rained, so dry, is 0.1. Complete the tree diagram. So remember, your branches have to add up to 1, so I can quickly finish that. So I finished that row. This one here is, it's dry. Okay, so dry is 0.9. And the probability that it's dry after it, let's just do it when, so rain, okay, so rain after it's day that has rained, rain after a day that hasn't rained is 0.1. 0.25. Okay, dry is 0.9, 0.1, and it's 0.25. What a pain in the bum of a tree diagram. Okay, leave it there. I'm just going to see my questions though. Okay, 3 days, 1 wet day, 2 rainy days, 3 dry days. Okay, so 3 dry days. We want dry, dry, dry. We just go along our branches, so it's 0.7 times 0.9 times 0.9. And you can do that on your calculator. I'm not doing it now. So just hit 1 hour. Exactly 1 wet day. Okay, so 1 wet day, we can have was it exactly 1 wet day? Sorry. Yeah. If it was at least, it would be different. Okay, exactly 1 wet day. So we can have dry, dry, rain. We can have dry, rain, dry. And we can have rain, dry, dry. Okay, so there are 3 possibilities. And the probability of each one is different. Okay, so these are not independent of each other. All right, dry, dry, rain. So we have 0.7. We've got dry, dry, rain, so 0.9. And then rain, 0.1. Plus the next one, dry, rain, dry, dry, rain, dry. So 0.7 times 0.1. And then dry, 0.25. And then the last one, rain, dry, dry, 0.3. Oops, that should be a multiply sign. Rain, dry, dry, so 0.25, 0.9. Okay, and then you can just plug that into your calculator. So just remember here, there's 3 different possibilities. So you add your different possibilities, but you multiply the branches. Okay, I want to leave that on there. What was the last one? At most 2 rainy days. So we want at most 2 rainy days. So we don't want 3 rainy days. Okay, so we can have at most 2. So it can be 2 days that are rainy, 1 day that's rainy, or no days that are rainy. And I'm going to keep, actually, can I undo that? Yeah. Okay, so we want the probability of less than or equal to 2 rainy days. And that's the same as 1 minus, what was it? 2 rainy days. I can't remember. 2 dry days. Okay, 1 minus all dry. Okay, because this is the only possibility that we don't want. Okay, so if we want at least 2 rainy days, we can't have 3 wet days. And you work that out before here. So you can just go ahead and do that on your calculator. I think we're done. Oh, who snuck that one in? All right, let's quickly get this one done. Okay, a game show has contestants selecting 2 random envelopes. There are plenty of envelopes, meaning that a contestant could select 2 envelopes with the same amount of money. In these envelopes could be $5, $10, or $20. Display the different possible outcomes. So you could have $10, $15, $25, $15, $20, $30, $25, $30, $40. Calculate the probability of winning an amount greater than $15. So you've got 1, 2, 3, 4, 5, 6. 6 out of 9 possibilities, which is 2/3. I'm going to have to leave those probabilities on there. I can rub out this one there. I did it again. Okay. If a contestant selects, is that the last question? Cool. If a contestant selects 2 notes that are the same, then they get to keep their winnings and pick another envelope. Consider that the probability of selecting each note is the same. What is the probability of a contestant winning $60? Okay, so this would be given that they got the same. Okay, so you'd only be looking at the 2 $5 notes, the 2 $10 notes, or the 2 $20 notes. And they got to, if a contestant selects 2 notes that are the same, then they get to keep their winnings and pick another envelope. Considering that the probability of selecting each note is the same, what is the probability of a contestant winning $60? So basically, the only way they can win $60 is to get 3 $20 notes. So the probability of getting $40 is 1 out of 9. And then the probability of selecting a $20 note is just 1 out of 3. So your probability is 1 over 27 chance of winning $60, which is pretty good. All right, and that's it. And I'm sorry for mumbling towards the end. Just over an hour. Good luck, girls. Bye-bye.